Docker is a very popular topic of conversation nowadays, and we're going to break down what it is, what it isn't, and why it's useful to you. It's not feasible to have different computers and servers for every application that we might want to run or interface with. This would be a big waste of resources, since not all applications are constantly running at full capacity, and most applications don't need the resources that exist on a modern server. The approach that has been used for a long time to deal with this is called virtualization. In virtualization, you have some hardware, you have an operating system, you have a hypervisor, which we'll get to in a second, and then on top of that, you have multiple VMs. Containers utilize a similar structure, but are different at the same time. You have a server and an operating system, but instead of using a hypervisor, you utilize some of the tools given by the Linux kernel, specifically namespaces, cgroups, and chroots, to break up the system into chunks called containers. Looking at the difference between a VM and a container, you'll see that there isn't a whole lot different, but the one difference that they do have is significant. A VM is created out of having an operating system, the libraries and dependencies that are necessary, and then the application that you want to run within that virtual machine. A container consists of the libraries and dependencies that you need in order to run that app and your application logic. The big difference here being that there is no operating system that is required inside of a container for it to run. As I mentioned before, containers are created using cgroups, namespaces, and chroots. Docker is not in that list. Docker is a system that interacts with the operating system on your behalf to create containers, but it is not actually the thing that creates containers, and Docker did not invent containers either. Now let's take a look at the tools that Docker provides you for interacting with the Linux operating system to create containers. When first working with Docker, you first start with a computer that's running Linux. Then you install the Docker daemon onto that server. You prepare to log in and interact with Docker Hub, the registry. And then you run commands from your Docker client. This Docker client can either be on the same server that is running the Docker daemon, or it can be on your own machine connected to the Docker daemon through a remote network. When you run Docker run Apache, you first talk to the Docker daemon. The Docker daemon will check and see if it has an Apache image that it can run. If it does not, it'll talk to Docker Hub. If Docker Hub can find the Apache image, it will return the contents of that image. The Docker daemon will then cache the image. Then the daemon will talk to the Linux operating system and manipulate the various tools that it needs as part of the Linux kernel in order to start the container. You can repeat this process with different applications. So if we run Docker run Rails, we will talk to the Docker daemon once again, talk to Docker Hub if we don't have a Rails image, and then have Docker talk to the operating system on our behalf to start a container that contains Rails. As I hope you've learned from this episode, Docker didn't create containers, but it does create containers for you. Docker makes it much easier to utilize containers to run your applications, and it also removes the need for a hypervisor and virtualization, which both reduces the cost and improves the utilization of server resources. The container standard that Docker provides is also incredibly useful because it makes working with containers created by others easier, and the flexibility and various solutions that you can find on Docker Hub are pretty amazing. I hope you enjoyed this video. Don't forget to like, subscribe, and leave a comment letting me know what you thought about it and what you would like to see me talk about in the future.